To understand machine learning, you have to start by thinking about data in your business. Do you have a dashboard that analysts view every day? Or maybe there's a report that your managers review each month. Both the dashboard and the report are examples of backward-looking data. They look at what happened in the past. Most data analysis in your organization is probably backward-looking. Analysis of historical data to calculate metrics or identify trends. But to create value in your business, you need to use that data to make decisions for future business. Let me give you an example. Suppose Maya leads the business strategy and operations team for an international airline. She might be looking at historical annual reports to establish a trend in customer purchasing patterns. She'd probably use this data to forecast annual sales and operational costs. But there's nothing new or transformational about this decision-making process. What if Maya could predict the satisfaction rate of each flight or predict customer complaints and get ahead of them? To do this effectively, she'd need to access a lot more data, including number of passengers per flight, duration of each flight, customer satisfaction ratings per flight, number of customer complaints per flight, factors that contributed to customer complaints, weather reports, seasonal indicators, and time to resolution for customer complaints. With all of these various data points, she might be able to predict the quality of a single flight and its customer complaints. But there are hundreds of flights each day. The real value for Maya would come from being able to make predictive insights for all flights all year round. More importantly, it would be far more valuable if she could dynamically adjust pricing or staff assignments or even catering based on the predictions. ML unlocks these capabilities and more. But what exactly is machine learning? To understand that, we need to step back and define artificial intelligence first. Artificial intelligence, or AI, is a broad field or term that describes any kind of machine capable of acting autonomously. Machine learning, or ML, is a specific branch within that field. Specifically, ML refers to computers that can learn from data without using a complex set of rules. Machine learning solves many kinds of problems. For the purposes of this course, we'll focus on a definition of ML that applies to numerical or classification problem types. I'll use this ML definition to guide your learning throughout the module. And here it is. ML is a way to use standard algorithms or standard models to analyze data in order to derive predictive insights and make repeated decisions at scale. Put simply, it's a way of teaching a computer how to solve problems by feeding it examples of the correct answers. Usually these problems are about predicting something. For example, you can predict how long it takes to travel from one location to another by feeding the computer examples of the completed journeys. Similarly, you can predict the estimated taxes owed by feeding the computer examples of tax filings. You do the same for predicting weather patterns over the next few days. More technically speaking, suppose you wanted to use machine learning to accurately label a photo of a fruit or vegetable the model has never seen before. You train an ML model, or the standard algorithm, using lots of images of fruits and vegetables, input data, and their correct labels, output data. As you train the ML model with more input data and corresponding output data, its predictions become more accurate when you feed it an image of a fruit or vegetable it hasn't seen before. Now that was an overly simplified example. We'll cover many more real-world examples throughout the module. Ultimately, the purpose of ML in a business is the same as all other disruptive new technologies: to enable organizations to better achieve their missions. To apply machine learning effectively, you need lots of data. In fact, you need lots of high-quality data to generate more and more accurate, meaningful predictions. In the next video, I'll examine factors that impact data quality.